Hi everyone, welcome to my YouTube channel. In this video, I'll show you how can we estimate the cost of steam in chemical process plant. As you know, in chemical process plant, steam is produced in steam boilers. These steam boilers run on fuel. This fuel can be natural gas or it can be mixed fuel gas or fuel oil. And the cost of steam is actually dominated by this fuel cost. I'll show you step-by-step method to estimate the cost of steam in Microsoft Excel platform. Please note that I have used the steam table add-in to perform the thermodynamic calculations. I provided the instructions about how to install and use steam table add-in in my previous video. You can watch that video and install the add-in. To demonstrate how to estimate the cost of steam, I have taken one example from the book by Robin Smith. So without further ado, let's dive into the example. So as for this example, we need to estimate the cost of steam for all the three levels. So in this steam generation plant, we have three different levels of steam: high pressure, medium pressure, and low pressure steam. And the pressure levels are known to us. The boiler feed water condition is also given to us. It is 100 degrees centigrade. So here, out of the deaerator, the boiler feed water that comes out, it is typically at its saturated liquid condition, and the temperature is 100 degrees centigrade. So we can back calculate the enthalpy associated with this boiler feed water in our calculation. The boiler data that is given to us is boiler efficiency 85% here, distribution losses around 10%. The distribution losses are nothing but steam leakage and some other heat losses that are happening inside the steam network. The cost data is like fuel cost is $4 per gigajoule of energy, electricity cost is given to us, and steam turbine information is like isentropic efficiency of the steam turbine is around 80%. So on the screen, what you are seeing is a solved example on Excel platform. Practical use of such kind of Excel-based model is you can conveniently check the effect of different inputs on your final result. For example, here the example uses the fuel cost of $4 per gigajoule of energy, and you can see what is the cost of your high pressure steam and other different levels of steam cost is calculated. Now, tomorrow or maybe after some time, if you get some new supplier who is ready to give you the natural gas with somewhat lower price, let's say with $3.5 per gigajoule, at that time, how your cost of steam changes, you can readily calculate. So here you can see as the fuel cost reduces, your steam cost also reduces. You can also get to know like what would happen if the existing supplier of your natural gas is wanting to increase the price from 4 to let's say $5 per gigajoule. So in that case, also we can see like our steam cost is increasing this much. So you can very easily discuss this impact of cost with your management. This is something that can be very useful to make some realistic business case when you are proposing any energy saving project. To explain this example a little bit in more detail or give you some hint like how to put few formula about steam tables, I have developed the second Excel sheet where I haven't put any numbers. So I will show you step by step how we can insert the formula from the steam table add-in. Before we start solving this example on Excel platform, I just want to let you know that in our Excel, steam table add-in is already activated. You can see that it is Excel add-in, this thermotables. This is the add-in that I showed you in our previous video, how to download this particular add-in from the internet and how to install it. So right now it's already activated mode. So because of this, now we can access the thermodynamic formula to calculate enthalpy and entropies. So first we are starting with the enthalpy associated with our high pressure steam. So it's a pressure, temperature, both things are known to us. And as you know that this formula of enthalpy, pressure, temperature, and H2O, so it is for the water. And you can see, if you can click this insert function, you can get to know what is the pressure unit. So pressure unit is kilopascal and temperature unit is degree centigrade. So yeah, we have everything in kilopascal and degree centigrade, so we can reference it. and the answer would be in kilojoules per kg. So this is the answer for the high pressure steam enthalpy. Now, I think we will not put here what is the temperature of medium pressure steam and low pressure steam right now, but we would go for our boiler feed water. This boiler feed water that actually comes out from the deaerator, and the boiler feed water is at saturated liquid condition, so we can easily calculate its enthalpy using this formula HL. L stands for the saturated liquid, and the thing that is known to us is not pressure, but here the temperature is known to us, and we are doing for H2O, so H2O, and I'm just referencing the cell. So this much kilojoules per kg is the enthalpy associated with the boiler feed water. Once these things are calculated, we can calculate what is the enthalpy change that is required from boiler feed water here to here, the stream that is entering to the HP steam header. So now we can calculate the enthalpy change between boiler feed water and high pressure steam. But the actual energy that is required to elevate this enthalpy, that would be influenced by the boiler efficiency and distribution loss. So this delta H divided by the efficiency of the boiler divided by our distribution losses, but it's like 10% is lost, so only 90% is being used. So 1 minus 10%. So this is the actual energy required in terms of fuel. So cost of HP steam is this much dollars per gigajoule, but we have information in kilojoules. So I'm just dividing this whole number with million. So this is dollars per kg. Typically the steam price is given in dollars per ton. So I'm just multiplying this value by 1000. So $14.6 per ton of high pressure steam. So this is the cost of high pressure steam. Now we can calculate the medium pressure steam also. So the price of medium pressure steam and the low pressure steam are usually discounted from the high pressure steam price to allow for the shaft work credit, and that can be gained by expanding the steam through the turbine. We need to calculate the shaft work generated by expanding the steam between levels, and the price this as equivalent to electricity, which could be generated by attaching the turbine to a dynamo, or else would be needed to run a motor to replace the turbine if it is used as a driver. The value of the shaft work then sets the discount between the steam at different levels. So now we calculate the shaft work generated by expanding the steam between this steam turbine from high pressure steam to medium pressure steam, and we will translate the shaft work to the power generation, and we will take credit of electricity generation and discount it from the high pressure steam price. So we will get the price of medium pressure steam. So we will start with the enthalpy at the high pressure steam. So that is already known to us, and entropy is something that you can calculate using SPT H2O. We have this information: pressure, temperature, and first we will start with the isentropic expansion. So we will just take same entropy, and here the enthalpy is like we know the pressure, we know the entropy, and it is for H2O. So this is the pressure and this is the entropy. So this much kilojoules per kg. So this isentropic enthalpy change is like H2 minus H1. Now the isentropic expansion efficiency that is given is 80%. Yes. So we will just multiply this number with our 80%. So this is the actual enthalpy change, and now we can calculate what would be the actual enthalpy at the outlet. So delta H plus H1 so 2940 is the enthalpy. We can also calculate what would be the outlet temperature of this stream. So that is temperature for the given uh, pH, maybe I think it's there, yes. Pressure, outlet pressure is this, and the enthalpy is known to us. So 250.3 degrees centigrade. If you try to look at what is the saturation temperature of maybe T sat yes for the given pressure of water, and so 184.1 is actually the saturation temperature of this medium pressure steam. So it is a good amount of superheating is there. So how much it is, you can see the 66.2 degrees centigrade of superheating is there in medium pressure. Power generation is simply H1 minus H2. So the value of this power generated would be like 270.8 multiplied by our cost of electricity, and the unit of this cost of electricity is dollars per kilowatt hour. So we need to take into account of the unit. So kilowatt hour, maybe let's divide this by 3600. So this is the dollars per kg of steam we are making this much money, zero. So we can take the credit for this on HP steam cost. So HP steam cost minus this much discount we can get, and because of this, we in tons it is like $9.33 per ton. So in very similar way we can do this calculation for LP steam as well. I hope you have found this video useful. You can download my Excel file from the link mentioned in the video description. As a plant process engineer, it's a valuable skill to be able to estimate the cost of important utility like this one, I mean steam cost. My humble suggestion is try to share your learnings with your colleagues or your fellow students. When you teach somebody some concept, you also develop better understanding about the concept. My other suggestion is if you don't get chance to share your knowledge, feel free to share this video with your colleagues or with your fellow students. When you care, you share. And trust me, people having great caring attitude make a great team. And only great team achieve something really impactful in chemical engineering. Thank you for watching.